When you draw the structure of a compound, simply paste this structure in Chem 3D and minimize its energy. Its energy is minimized. Now simply Control plus S from your keyboard. And
Excuse me.
yes. Yes. Yes, Mubashir, what you want to ask?
Hello.
Yes, yes.
Yeah, I'm asking that you minimize the energy by clicking on MM2, but we have another minimization option. If you go to the calculation, and there is another thing written MMF94, something like that. I saw.
In same
Did,
Chem 3D?
yeah. Just close this window, save as, for example.
I save this file
Yeah,
in the
go to calculation, which is adjacent to surface. Yeah, open it, and MMF94. No, go downward. Yes. And here calculate third option. Yeah, or second option, I think. Second one.
perform MMF.
Minimization. Now click it. So I think it also does. Yes, go to run. Yeah.
Okay. We can also use this shortcut, or we can use this one. Okay, I will tell you something more. For example, this is we have this simple compound. Okay, this is our simple compound. For this purpose, we minimize energy from this. If sometimes we face error when we have a complex system, in a complex system, for example, we have such type of items that are not running here. So for this purpose, we can use all of these options. We will try to minimize energy by using any of this option. If its energy is minimized by using these options, then it will be good. Otherwise, we will use another software. I will also tell you about this. Okay. Its energy is
Okay, thank you.
Its energy is minimized. Simply Control plus S. I have already saved it at desktop. Okay, I have saved this file at desktop. I have created a separate folder for it. And now I will tell you about another case in which for example, you want to minimize the energy by using this software, Chem 3D, but it is not working. For this purpose, what you have to do is simply go to Chem 3D. As you have drawn already the structure of compound, save it at desktop, and give it name, for example, C1. And from here change its type to SDF. Oh, I think I want to save it. I was okay. Save as desktop C1 and SDF. What is the problem? Okay, this file is saved here. Now I simply go to another software that's name is Avogadro. Avogadro software, I simply open it. It is freely available on internet. You can simply install it from Google. If energy minimization is not done by Chem3D, then you use it. What you have to do is simply drag this to Avogadro software, and from here, tap on yes. Now this is loaded here. From here, what you have to do is go to extension, and from here go to molecular mechanics and set up force field. Different molecule have different type of force field. For example, complex system will not run at this type of force field. They need UWF and okay. If you simply you have to select this one and okay, and then go to extension and optimize geometry. Then its geometry is optimized. In case it is not accepting the force field like this one, and geometry optimization will be done at this one, then it automatically send a notification when you go to optimization, and it will say that its optimization will not proceed with this type of force field. You have to change force field to this one or any other field. It will suggest you and automatically correct it. Then when its optimization is done, you go to simply save as. Save as at desktop, save it and save it in the form of mol. You can save it in the form of mol 2, and also you can save it in the form of pdb. I save it in the form of mol 2. I want to replace it, and this is okay. Now compound structure that we want to run its DFT is prepared. Next, you have to go to search bar and search for software Gaussian. This one, Gauss view. Open it. Simply drag this here. The structure is loaded in Gauss view, and from here you can also do one thing. Here is an option of cleanup. This cleanup also clean the whole structure. Okay. Next, what you have to do is now you have to set up some commands, set up some settings to proceed. At this, you go to calculate and Gaussian calculation setup. You can simply select from here or pressing Ctrl plus G from your keyboard. Go to energy now. Here, go to energy and change it to optimization plus frequency. Next, go to method. From here, as you are doing DFT, so from here you have to select DFT. You have to select DFT, and from here you have to functional and select basic set. For this purpose, you have to do literature according to your compound. As our compound is simple, so we can use this type of functional set and basic set. Our calculation can also done at this basic set, but in mostly papers, these three sets are reported. Select anyone, it's not a problem. From here, select D, and from here, P. Next, you have to choose its title, what to give, want to give its name, compound, run. Next, go to link. Now, this is the main thing. First of all, if I show you this. For example, you want to run DFT, and in DFT, you just want to find out its optimized geometry and its ESP, MEP, and homologue. For this purpose, you do not need any type of check file. But if you want to find a TDOS graph, just like I mentioned here, TDOS graph and other RDG graph, for this purpose, you have to create a dot check file separately. For example, I just want to run all the calculation. I want all type of analysis. For all our type of analysis, I go to here and I do not want this one file and I change it to do not save. Okay. And next thing is, as I have already told you that if our compound structure is small, then it will take a minimum 1 to 2 hours to complete. But if compound structure is a large, number of atoms will increase. For example, in this compound, as you see here, total number of atoms present are 9 atoms. Okay, 9 atoms mean that a compound is not much larger. It will be done within 5 to 10 minutes. Its calculation will take 5 to 10 minutes. But when number of atoms will increase from 9 to 20, 30, 40, then calculation run time will be increased in the same way. For this purpose, we do not use simple PCs or simple laptops or a computer. We need a heavy system in which a calculation will uh, run quickly. For this, we will use these two options. For example, I have a system in which four processor and I want to use all the processor, and then I will change it to 4. If my system specification is much than 4, then I change it from here. For example, I have 9 processor or 8 processor, then I change it from here. And in the same way, we can also change the memory limit. We can specify it, where we can, for example, specify it to 1024 and change it to GBs. Okay. By doing this, calculation run time will be load and calculation will done very soon. But okay, next, what we have to give some additional keywords, like I gave SCF is equal to XQC. I give this one. I search these from literature, and now I simply submit this file. Save it. And when you are doing calculation, the best thing is that you have to create a separate folder for each compound. I simply go to DFT because I created for this. I give it name C1 and save it. And click on yes. Now you can see that here is some sort of error. I simply tap on OK. And you see here the link is dead. When link is dead, it indicates that calculation is not running smoothly. The calculations are stopped. So this type of file will be open. You have to go to end of this file. Now you can see here it is saying that you have selected memory in GB and processor 8. Will use up to 8 processor by sharing memory. It is indicating that there is a problem regarding processor and GB. To sort out this problem, I simply go to same file. I go to same file, click on it, and from here I simply press Ctrl plus G from keyboard. Calculation is saying that you have not selected the processor correctly. For this, I will use a 4 processor and run it again. I run it again. If I face same type of error, it means that there is a problem of processor. If you face still error in 3 processor, you have to change it to 2, then change it to 1. And if still face error, that is best you go to default. Okay, you go to default. And also memory limit was also an issue, so I simply change it to this one, and again I will submit it and save it. I want to overwrite it. Yes. Okay, again an error is shown. Now we can check what type of error it is saying. Now you see here it is indicating again error is of memory. So close this file, again open Ctrl+G, and from here change this option to lower. Keep lower and MBs. Now submit, save, and yes. Now you can see here the calculations are running smoothly. It means our file is created successfully. Now I simply close this one, and it will take time according to the type of atoms, according to the number of atoms present in our molecule. I choose a small molecule. The total number of atoms present in it was 9 atoms. It will take about 5 to 10 minutes to proceed. When calculation is completed, a small dialog box will appear, yes or no option, asking about either you want to save this file or not. Then you have to simply tap on yes, then file will be saved. Okay, now if anyone have question regarding this, then please ask because it will take some time.
Okay. Ma'am, first of all, tell me what is the RAM of your laptop which you are working?
Okay, I will check this. I do not remember, but I think 16.
Could you show me so that we can
Okay.
repeat the same thing in our
16.
16 GB RAM and
8 processor I have, but when I have 8 processor, but when I run calculation and I am selecting 8 processor, then calculation will not run. In fact, it not run on 4 processor. That's why when I am running my calculation on my PC, I do not select the option of processor. I pick the default option.
okay. Now my second question is up to how much GB could we use for running that job in Gaussian 9? Right now you are using 1 GB.
Yes, I am using 1 GB, and this is all depend on your system. As I mentioned, I can run calculation 2 to 3 times that you can all of you can understand what I want to teach you. When I use in GB, then it do not accept it. When I give it in the form of MBs, it accept it, and the calculations are running smoothly. So
because
yes.
Yes, please. I have used Gaussian, and it does not go beyond 2 GB.
Okay, it means that your system system specification is this, and it will not use more than GBs.
No, madam. I have another query. This is not because of our system. This is because of the restriction in Gaussian 9. It does not go beyond 2 GB. If it were Gaussian 16, it would go much higher.
Yes, yes, Gaussian have some restriction, some because that I am using the software Gaussian 9, and it has also restriction of some atoms, number of atoms. If the limit of number of atoms is exceeded, then it will not also run this one. So it has some specifications.
And I think that it will take much higher time, not 10 minutes. It will take too much time because you chose 631G. It is a very larger basis set.
Yes, it will take, because there and it also depend on number of atoms. As number of atoms are 9, it may take
Yeah.
10 to 20 minutes.
Yes, and when we go to the third group element, third period element, sulfur, it increases too much time.
Yes, as and when we are moving further on D block element, it will take more time. It number calculation run time will be depend on both size of atom and also number of atoms.
Okay. Because I have oh, that's complete. Good, bravo.
It's done. Now simply tap on yes. When you tap on yes, then this window will be closed. Okay, now we go to our folder. And here you can see here our file is saved. This is the input file and this is the output file that is run in Gaussian. I do not need this file. I simply delete it. Okay, this is output file. Simply tap on it. It is in the form of notepad. Oh, okay, open this file and move at the end. If you see here, it is a normal termination of Gaussian. It indicates that your calculation is run smoothly and there is no problem. All the things are correctly, and you can find here. You can find optimized geometry from this file. Now you have to close this one. Next, what you have to do is create a .check file for obtaining the optimized geometry. For this purpose, we simply again open wash view. And now the output file that was last generated by a Gaussian, simply drag this file into Gauss view. Okay, now here you have to give us some more additional changes, give some more commands, and by this at the end a new file is generated, that is .check file. For this purpose, I will simply press Ctrl+G from my keyboard, and now from here you have to change its job type. From here you have to change it to energy. As you see here, last time the file we have created in this, we do not need a .check file, but here we want to form a file that is in the form of .check, and that is our main file. So we can change it to default name and go to pop. From here you have to change some option. You have to change level of output to full, and you have to perform NBO calculation at full NBO. Now submit it. Here you can give it name C1 check. Save it.